Let's find the maximum deflection and rotation for this simply supported beam using the moment area method. And we know for this simply supported beam, the bending moment diagram is piecewise linear and has a magnitude of PL on 4 in the middle, and dividing through by EI gives the curvature diagram. Now if we designate this point A and this point B, then theta B relative to A can be obtained by integrating the curvature, which is M on EI, over X, and in this case we integrate from X equals 0 to X equals L on 2. And given that the curvature diagram is linear, we can obtain the area by simple geometry. So given this distance here is L on 2, the area is 1/2 by the base of the triangle by the height of the triangle. So that gives PL squared on 16 EI. And as we know, that's theta B minus theta A. And we know that by symmetry of the beam, the slope of the tangent to the curve is 0 at B, and the slope of the tangent to the curve at A is negative. So that means if this is 0, then this equation here gives theta A is minus PL squared on 16 EI. And as expected, theta is clockwise at A. Now because the curvature diagram has a linear geometry, we can find the tangent at A relative to B using the centroid definition and multiply by the integral of the curvature over X from X equals 0 to X equals L on 2. So that gives the distance between a tangent at B and a tangent at A at A. So that will be tangent at A relative to B. And we can see that that's going to give us the maximum deflection. Now the centroid of a triangular area is at 2/3 of the length of the triangle, so that will be equal to 2/3 by L on 2, being the length of the triangle. And we multiply this by the integral, which is the area in the triangle, and we evaluated this already. So that will be PL squared on 16 EI. And if we cancel out the 2's, we see that the maximum deflection has a magnitude of PL cubed on 48 EI. And note that this distance between the tangents is below the beam, so we can just put a negative sign here. Please subscribe, like and comment to help me reach more students.